Hi everyone, welcome back to Stat 610. In our first week of this online version of Stat 610, we'll be going over binomial probability distributions and normal probability distributions. And so for a lot of you this may be a review. For some of you this may be some new material depending on where you are at in your Stat 10 course. The goal of this lesson is first to practice identifying whether an exercise involves a binomial probability distribution or a normal probability distribution or neither. It could be something else. Another goal of this is just to practice solving those kinds of problems. The first example we'll look at says about 40% of eligible California adults voted in the 2018 elections. A local political scientist recently surveyed a random sample of 20 California adults and asked each individual whether they voted in the 2018 elections. What is the probability that fewer than 8 of the 20 California adults voted in the 2018 elections? One thing to note is this is a sample of 20 California adults. So our sample size is 20. Another thing to note is the 40%. So first, we want to identify, is this involving a binomial distribution or a normal distribution or neither? One thing is that in an exercise involving a normal distribution, the exercise usually mentions the word normal. It will usually say this distribution is approximately normal. This exercise does not mention anything about the distribution being normal, so this is probably not a normal distribution. And on the other hand, this involves the variable involved has only two possible outcomes. Whenever they ask each individual whether they voted, their responses can only be yes or no. And that's a big clue that this is involving a binomial distribution. There are only two possible outcomes for this variable. To solve this, the question is, we want to find the probability that fewer than 8 of the 20 California adults voted in the 2018 elections. We're looking for this probability. There are different ways of finding this probability, and I'm going to go over and review each of these different ways. Remember that when you're calculating a binomial probability for a range of outcomes, there's a certain way that you would do that. One way to do that is to use a formula for binomial probabilities. here is the formula. Also, we'll want to note that the probability that x is less than 8, that's the same as saying the probability that x is 0, 1, 2, 3, 4, 5, 6, or 7. And if you want to find all those probabilities of each of those outcomes, you would find each of them individually and then add them together. So probability of 0 plus probability 1 plus probability 2, all the way to the probability of 7. And that means that you would use the formula to find each of these individual probabilities. So the probability that 0 out of 20 voted in the elections is this formula right here. Just plugging in 0 for the x, 20 is the sample size, and then the 0.40 is from the 40%. And then here's the probability for 1 out of 20 voting in those elections would be this formula right here. If you do that for all of them, all the way up to the probability that 7 out of 20 voted in those elections, and you add them all up, it would come out to 0.4159. Another way to work this out is to use a graphing calculator. If you're using a Casio graphing calculator, you would use the function called BCD. If you're using a TI-83 or 84, you would use the function Binomial CDF. And before you start using these functions, you'll want to keep in mind that they're programmed to calculate the probability that x is less than or equal to some number. And that means that you'll have to rewrite the probability so that it's in that form. So the probability that x is less than 8, again, that means that x could be 0, 1, 2, 3, 4, 5, 6, or 7. And that's equivalent to saying the probability that x is less than or equal to 7. And this is what you'll use when you enter it into the calculator. So if you're using a Casio graphing calculator, you would follow these steps to get to the function BCD. And when you get to BCD, you'll want to enter 7 for your x, 20 for the n, the number of trials, and for the p, you'll enter in 0.40 for the 40%. If you're using a TI-83 or 84, you'll follow these steps, use Binomial CDF, and then enter in the n, which is 20, the p, which is 0.40, and the x, which is 7. And you'll come out with the same result, 0.4159. A third way to work out this probability is by using a table. And if you're using the Sullivan statistics book, this table is called Table 4. If you're using another book, the table may be called something differently. But these tables are usually similar to each other. In Table 4 in particular, you'll still have to rewrite your probability in this form so that it's in the form of less than or equal to some value. And again, the probability that x is less than 8 is equivalent to saying the probability that x is less than or equal to 7. And so if you're using a table, you would go to Table 4, you would look for an n of 20, so here's an n of 20, look for an x of 7, here's 7 for the x's, and then on top are the p's. We want to find the p of 0.40. Go down and see where they line up, and they line up right here. And that's the same as what you would get on a formula or on the calculator. So we just line these all up. And you get that same result, 0.4159. In the next video, we'll take a look at another example.